We are starting with exercise number 2. Question number 1. Limit x approaching towards 0, 7x squared plus 5x minus 5x plus 1. Now this problem is not asked for whether the limit is existing or not. You just have to solve it. Now there is no denominator over here. Put the value of x as 0 directly. Okay. And this cannot be simplified further as well. So the answer is 1. Question number 2. Limit x approaching towards 1, x minus 1, x plus 1. So when you put the value of x as 1 over here, the denominator does not turn out to be 0. So you can directly put the value of x as 1 over here. So 0 upon 2, which is equal to 0. Okay. Third question. Limit x approaching towards 2, x square plus 5x plus 6 upon 3x square minus 2x square minus 3x. Now put the value of x as 2 over here. So 2 square, that is 4 into 2, 8, 8 minus 3 into 2, 6. 8 minus 6 is 2. So this is not 0. If we put the value of x as 2, the denominator is not 0. So directly put the value of x as 2 and you may solve this. Okay. That was question number 3. Question number 4. X approaches 0. Ax plus b, cx plus d. Put the value of x as 0 in the denominator. The denominator entirely is not equal to 0. So you can simply put the value of x as 0 in the entire problem. Okay. Keep an eye on the denominator. Question number 5. Now specifically they are asking you 5 plus. So that is RHL. Okay. So this we did in the last exercise. So let x is equal to 5 plus h. As x approaches 5, h will approach 0. So limit h approaches 0, 5 plus h minus 5, modulus of 5 plus h minus 5. So this is h upon modulus of h. Okay. So limit h approaches 0, h upon h, which is 1. That was question number 5. Question number 6. X approaches 5 minus x plus 5, modulus of x plus 5. Now this time it is LHN. So x is equal to 5 minus h. As x approaches 5, h will approach 0. So limit h approaches 0, 5 minus h plus 5 upon modulus of 5 minus h plus 5. So limit h approaches 0, 10 minus h, modulus of 10 minus h. Okay. Now this we cannot further simplify. Okay. So put the value of h as 0. So this is going to be 10 upon 10, which is 1. Question number 7. Now prior to that, let us understand this greatest integer function less than or equal to. This is called as greatest integer function less than or equal to. Okay. Now whenever there is some integer within the box bracket. So for integers, the greatest integer function is the same integer. Okay. It is the same integer. Now let us take some decimal values. 1.2. So on a number line, 1.2 lies over here. So take the lesser integer, less than or equal to. So it is 1. 2.6. So 2.6 is between 2 and 3. So take the lesser integer, left hand side integer. So this is equal to 2. Minus 3.2. So minus 3.2 lies between minus 3 and 4. Somewhere here. So take the lesser integer. Answer is minus 4. Okay. Minus 1.6. Minus 1.6 lies between minus 2 and minus 1. Over here, somewhere. Okay. So take the here. This is minus 2. Fine. So we should know this greatest integer function. Question number 7. X approaches 5 plus x minus greatest integer function of x. Now since this is RHL, let x is equal to 5 plus h. As x approaches 5, h will approach 0. So limit h approaching 0, 5 plus h minus greatest integer of 5 plus h. Okay, now there is no denominator, so just put the value of h as 0 over here. So this is going to be 5 minus greatest integer of 5, which is 5. So the answer is 0 because box of 5 is 5. This is greatest integer function. So integer remains the same. Let's go to question number 8. Limit x approaches 1 minus x square minus 1 modulus of x minus 1. This is LHL because they have mentioned 1 minus. Let x is equal to 1 minus h. As x approaches 1, h will approach 0. So limit h approaches 0. 1 minus h the whole square minus 1. 1 minus h minus 1. Okay. Now we have to simplify this. Okay. 1 plus h square minus 2h minus 1 and modulus of 1 plus h square minus 2h minus 1. So 1 is getting cancelled. Okay. 1 and 1 is getting cancelled over here. So limit h approaching towards 0. Take h common. H into h minus 2. Down also I'll take h into h minus 2. Okay. So guys, I think I just made a small error over here. This part is not correct. Copied it wrong. Yeah. So the modulus of this one and this one will go. So we'll be left with minus h. So in the numerator, take h common, h minus 2, and modulus of minus h is h. H will get cancelled. 0 minus 2. The answer is minus 2. Okay. That was your question number 8. Let's go to question number 9. Limit x approaching towards 2 log to the base 10 x raised to 6 plus root of x square plus 1292. Okay. Now see guys, we need to prove that this limit is equal to 2. The answer of this limit is equal to 2. There is no denominator over here. So just put the value of x as 2. 2 square plus 1292. So log of 2 raised to 6, which is 64 plus root of 1296. 1296 is 36. Okay. Root of 1296 is 36. So this is 100. Okay. Now change of base. Okay. Log a to the base b is equal to log a upon log b. Okay. So log 100 to the base 10 is log 100 upon log 10. Now log 100 will be 10 square. Okay. 100 is written as 10 square. Then log a raised to b is b log a. So 2 log 10 upon log 10. So log 10 is getting cancelled. We are left with 2. Okay. Hence proved. Question number 10. Question number 10. F of x is equal to 4 minus 7x upon 3x plus 4. 4 minus 7x upon 3x plus 4. L is nothing but it is given limit of x approaching to f of x. So limit x approaching towards to f of x. What is f of x? 4 minus 7x upon 3x plus 4. Now you can put the value of x as 2 over here because that doesn't make the denominator 0. Okay, so in numerator as well as denominator we'll put the value of x as 2. Okay, so 4 minus 14 upon 6 plus 4, which is 10. So minus, this is going to be minus 1. This is L. M, I think, just a second, no, that's correct. So M, limit x approaching towards 0, f of x. F of x is equal to 4 minus 7x upon 3x plus 4. So put x as 0. So 4 minus 0 upon 0 plus 4. So this is 1. So we need to find out the quadratic equation whose roots are 1 upon L and 1 upon M. Okay. So quadratic equation, x square minus sum of the roots into x plus product of the roots. The roots are not L and M. The roots are 1 upon L and 1 upon M. Okay. So 1 upon minus 1 plus 1 upon 1. Okay, plus 1 upon minus 1 into 1 upon 1. See, because L is minus 1, M is 1, we have already done that. So x square minus 0x, and this is minus 1. So x square minus 1 is equal to 0. This is the required quadratic equation.